In the previous video, we looked at the basic tangent function. So in this video, we're going to take a look at variants of the tangent function. So what we're going to do is we are going to be able to find the equations of the asymptotes for the given tangent function. And then what we're going to do is we are going to find the equation of two consecutive asymptotes. Okay, that should help us to be able to graph it. We're going to graph the function using those asymptotes. And then finally, we're going to graph the function using technology. Recall that the tangent function has asymptotes when x is equal to pi over 2 plus pi n, where n is an integer, right? And so for us to be able to find the equations of the asymptotes, what we're going to do is we're just going to set the interior function of the tangent equal to pi halves plus pi over n. And so that means that the equation of the asymptotes for this function, 3 tangent of 2x, is going to be x, or 2x, excuse me, is going to be equal to pi halves plus pi n. To solve for x, we're just going to divide everything by 2. And so that means that x is going to be equal to pi over 4. Okay, so when we simplify this, we could multiply by the reciprocal of 2, which would be 1/2, plus pi n over 2, okay, where n is an integer. Right? So this is the equation of all the asymptotes of the tangent function. For us to find two consecutive asymptotes, we just have to have two consecutive integers, such as 0 and 1. Okay, so let's let n be equal to 0. That's really easy because we would get x equals pi over 4 plus pi times 0 over 2, or this means that x is going to be pi fourths. Now, another consecutive asymptote would occur at the value when n is equal to 1. And so that means that x is going to be equal to pi fourths plus pi times 1 divided by 2. To get a common denominator, remember, all we do is we just multiply whatever we need to get to 4. So in this case, we multiply by 2 over 2. And so that's going to mean that we end up with x is going to be equal to pi fourths plus 2 pi fourths, or finally, another asymptote occurs at 3 pi over 4. All right, so those are our two consecutive asymptotes, okay? And so if I was to plot those on a graph, okay, pi fourths is about 0.78 or something like that, so maybe like right about here, okay? And then 3 pi fourths, if I was to plug that into a calculator, 2.3, 2.4, or something like that. But regardless, we'll just plot it. That line has nothing to do. It just kind of appeared there. And this would be another asymptote. Okay. And we recall that the general tangent function looked something like this. So that's what one period of the tangent function should look like. Okay. Now, of course, we know that the tangent function is periodic, so it might look something like this as well. Okay, but the only thing I was asking for in this problem, or the problem was asking for, was the right tangent. Now, of course, we can always check to see what the real function looks like by using technology. Okay, so let's take a look at our technology, and our technology would say that if we had 3 tangents of 2x, and we probably have to have y equals, okay? And we want to zoom in, obviously. What would also be helpful is if we plotted those two consecutive asymptotes. So remember, we had pi over 4, right? And that seems like it works really well, right? And then we also had 3 pi fourths, right? So what we had, the one that we graphed, was the function that's between these two asymptotes, okay? Now, if I was to plug in something like x equals negative 3 pi fourths, all right, that would be another asymptote, and then also x equals negative pi over 4, okay? So this was the other one that we graphed with this purple, between the purple and the red asymptote, right? So that's what our tangent function looks like, okay? And again, tangent function does model a few real life phenomena. We'll get to that a little bit later in the course. Now, another example would be this negative 2 1/3 x plus pi fourths minus 1. Okay, so again, we're trying to find the asymptotes, which means that we're going to set this interior function equal to pi halves plus pi over n. So we would have 1/3 x plus pi over 4 equals pi halves plus pi n. Right? And then to solve this, we would start by subtracting pi fourths. So I subtract pi fourths from here, and then I'm going to subtract pi fourths from here. Now, when I subtract these, I need a common denominator. Okay, so off the side, I'll take care of pi fourths minus, or pi halves minus pi fourths, or 2 pi fourths minus pi fourths, which would be equal to pi fourths. Okay? So that means that I would have 1/3 x equals pi fourths plus pi n. And the last thing I'm going to do to find the equation of all asymptotes is I'm going to multiply both sides by 3. Okay, so 3 times a third, that cancels this out. So we would get x equals 3 pi over 4. And then we would also make sure to multiply the 3 by pi over n, or pi n. So that would be 3 pi n, okay, where n is an integer. So this would be the equation of all asymptotes of this function. We want 2 consecutive asymptotes, okay? So we're going to let n equal 0. And that's easy because whenever n is equal to 0, that's going to wipe out this 3 pi n, and we would just end up with 3 pi fourths, okay? So one asymptote is going to be at 3 pi fourths, and then another asymptote when n equals 1. Now this one's a little bit tougher to get because we'd have to add, so that's going to be 3 pi over 4 plus 3 pi times 1. And then we would need a common denominator, so x would be 3 pi fourths. We'd multiply the top and the bottom by 4, right? So this would become 12 pi fourths. And then ultimately x would become 15 pi fourths. So that's the equation of the other asymptote for this. Right? If I was to graph this by hand, okay, so we would have 3 pi fourths maybe right about here. Now 15 pi fourths, if we were to kind of get an estimate as to what that value is, okay, 15 pi over 4 is 11.8, okay, so almost 12. So that's a huge distance compared to the other ones between our asymptotes, okay? So like maybe way over here, all right, would be our other asymptote. All right, now, notice that we have a -2 as the coefficient. And remember, that's going to flip it in the x-axis, okay? So there's a reflection here, okay, just like every other function we've looked at. Right? And then we're going to shift down 1 unit, okay, which really doesn't matter too much. So remember, usually our function is increasing between the asymptotes, but we're going to flip it over. So it should be decreasing. All right. So if I was to kind of get an idea as to what this looked like, all right, maybe something like that. Okay. And again, we're just trying to get an idea of what this tangent function looks like. Okay. Now, again, this is periodic. Okay, so that means that there's another graph or another tangent iteration over here that does something like that between the asymptotes. Okay, so that might be what our tangent function kind of looks like. Okay, if we were asked to do like, a 5-minute sketch of this thing, that's what we could probably get. Okay, now, of course, technology is going to tell us something different. So let's take a look. And remember, we had for our function, let me get rid of all these. We had -2 tangent of 1/3 x plus pi over 4 minus 1, right? So I'm going to zoom out. And what probably is going to be helpful for us is to plot those asymptotes that we found. Remember, 3 pi fourths was one of them. Okay, so that looks good. At least that substantiates our graph. Okay, the other one we had was 15 pi fourths. So that one's a little scary. All right. Oh, I forgot the pi in there. That would be helpful, right? And even though it's a pretty long ways away, it certainly looks like that it substantiates what we thought was going to happen. Okay. The other one that we plotted was -9 pi over 4. All right. And what I did was I just subtracted 12 pi fourths from 3 pi fourths. Okay. That was the one that where we got over here. All right. Although we didn't compute it and I didn't ask you to compute it, this is all I was really asking for with this problem was to kind of get a general graph of this. Okay. Now, if we zoomed out using Desmos, we know that this could go on forever. Okay. And notice how long it is between the periods of this tangent cycle. All right, so that's our tangent function. Okay, so key takeaways, asymptotes, remember that they're between pi halves plus pi n. Okay, and then be careful of these reflections and those sorts of things, and just set this interior angle or this interior function equal to the pi halves plus pi over n. All right, so in the next video series, we're going to take a look at the cotangent